Hi, hello everyone. Welcome to Vision classes. It's a classes for IGCSE, GCSE, IB student. We have a student across the more than 10 countries. I hope you are busy in your revision schedule, past year paper discussion and things like that. And along with that, I hope you all might be enjoying the FIFA World Cup as well. And yes, I am too enjoying this moment with my student, right? So they all updating their favorite team to win. So suppose if you have any favorite team, even you can update in the comment box. Today we have to discuss just one of the interesting topic, that is topic 4 of AS and A level discrete random variable. It's a AS and A level statistic paper 1 topic. Okay, so I hope you must have gone through this topic. So what we'll do, as your papers are next to next month, so you need to have some kind of revision to touch the topic again, right? So what I will do is that I will just make the 3 videos, part 1, part 2, part 3, to explain the what's a discrete random variable, their concepts, and I will within that video also I will discuss at least 2 to 3 past year paper questions on those topics. So here, discrete random variable, it includes 3 main topics. Firstly, here this is probability distribution, first one, and then secondly binomial distribution, and third one is geometric distribution. Okay, GD. So PD, GD and BD. So these are the 3 subtopics are there in the discrete random variable, and those are very easy, and you can score out marks here, and you will get each year at least 1 question from this 3 topic. So here basically you will get around 10 mark question. So the statistic, I hope you might be knowing statistic 1 S1 paper of 50 mark, right? And you have 5 topics are there. So out of 5 topics, 10 marks are distributed for each and every topic. So one topic is discrete random variable, means this topic weightage of 10 marks, right? So you have to focus this topic as well. Don't miss out, because these are the really easy concepts, and once you've done with or gone with this topic, it's really easy for you. So in this topic, this is part 1, so I will discuss just a probability distribution. So in a probability distribution, you have all the random discrete variable x are given. So you have to take the sum of or whatever the given thing or they have asked in the example. So it's a probability of sum of all the probability x is equal to, let's say, x, which is equal to 1 always. So this is sum of all the probabilities is always 1 in case of probability distribution. Fine. And then nextly you have a concept called the mean, or it is also called the expectance E of x. So E of x is denoted by mu, which is E of x, right? And the E of x is nothing but summation of x times all the probabilities. Okay, probabilities, whatever the number of probabilities are there, you have to take the probability times x is the expectance, and then you have a variance var of x. So this is first one, second one is expectance, and third one is var of x. Var of x is nothing but you have to take the sigma square. Sigma square is var of x. So var of x is basically you have to take the summation of x times x minus mu bracket square times p. Okay, x minus mu bracket square times p. There is another formula which is summation of x square times p minus E of x bracket square. This is the formula most of the cases we use. Okay, this is all about the probability distribution. Let's go to the question number 1. The question number 1 is from a probability statistic paper 1, May June 2021. You can see here. We'll straight away move on to question number 7. Question number 7 says that the Sharma knows she has 3 tin of carrot 2 tins of peas and then 2 tins of sweet corn in her cupboard. Okay, so all tins are same shape and same size, but labels have been removed. The Sharma does not know what each tin contains. The Sharma wants the carrot. Here she wants carrot for her meal, but she starts opening the tin one at a time, the chosen randomly until she opens the tin of carrot. The random variable x is the number of tins she opens. So see here, basically what she does is in her cupboard, actually, let's say take a cupboard, three carrots are there, right? One, two, three carrots, and then two peas, right? Two peas, and then two sweet corn, right? Two sweet corn. But she want just a carrot, so nothing to do with this four, right? So you have a three carrot and then four other teens, peas and sweet corn. So basically what you need to do is that you have to take just a probability of not carrot and probability of just a carrot. In the first case, probability of x is equal to 3 means she opens the 3 times, isn't it? 3 times means basically why she opens 3 times, because she hasn't got the first 2 times. That's as simple as that, isn't it? So basically here we will solve the first part. First part says she has x, she opened thrice, means she got nothing in the first time, then second time also she doesn't got the anything, right? Not carrot, and then third time she got the carrot, right? So probability of not getting the carrot is 4 over 7, because 4 other teens are there apart from the carrot, and the probability of getting the carrot is just a 3 over 7, isn't it? Okay, so probability of not getting firstly carrot is 4 over 7. Then she opened the first one, that's why she left with 3 not carrot and 6 teens are left, right? Third time she got the carrot, right? Out of 3 she got she has a now 5 teens are there, right? So it's a 3 over 5. So not carrot is 4 over 7, 3 over 6 and 3 over 5. Getting it? This is simple, but you have to understand this trick. Okay, until unless you understand this trick, you will not get the answer. That's as simple as that. Fine. Then nextly you have to draw the probability distribution table for x, right? So here how many tins of not carrot? It's a 4 tins are there. So at least she need to open 5 tins so that she will get the carrot. Okay, so we will make the probability distribution table here first of all. Okay, so I will just make the simple for you. So the probability distribution for when she opens up for three tins, right? So if you multiply and simplify, okay, then you will get straight away 6 over 35. Okay, this answer, that's it, and this is 2 marks, right? Then you have for B part, you have to make the probability distribution table. So for the probability distribution table, so you have to make it like this. She opens first tin, okay, she got in a first instance, she got the carrot in second instance, she got the third instance, she got the fourth instant, she got the fifth instant, like this. So you have to write down this all these probabilities, right? And here let's say the x is equal to 1 means she got the in first instance. So how many carrots are there? 3, right? So it's a 3 over 7 is the straight away probability. Then because she got the carrot, okay, then she need to open x is equal to 2 teens. Okay, so x is equal to teens. Fine. So here she need to open 2 times because in a first instance she got the not carrot, okay, and times she got second instance she got the carrot. Okay, not NC means not carrot. Fine. So here not carrot means how many not carrot? It's a 4 over 7 times it's a carrot is 3 over, you left with 6 tins now, 3 over 6. So total probability you will get here, 3 times 2 is 6, right? And 2 times 1 is 2, 2 times 2 is 4. So it's a 2 over 7 is the probability in the simplest form. Then you have to open 3 tins, and for 3 tins we already calculated in a first part. So it's a not carat times not carat times third time she got the carat, so it's automatically 4 over 7, then 3 over 6 times 3 over 5, so you will get 6 over 35. Okay, and that's answer, right? Then nextly you have to open 4 tins, so x is equal to 4 tins. So why you need to open 4 tins? Because in the first 3 cases you haven't got the carat, that's why. Okay, not carat, not carat, not carat, and then in the last instance you got the carat. So 4 over 7 times 3 over 6 times 2 over 5. Okay, in these 3 instances you haven't got the carat, so you have to open the carat. Lastly you left with 3 carats are there out of 4. So here simplify this one, this 3 times 2 is 6, this 6 cancel out, 4 get cancel out, and you left with here is equal to 3 over 7 times 5 is 35. Okay, then nextly x is equal to 5 tins you have to open. So not carat times not carat times not carat times not carat times carat. Okay, so 4 over 7 times 3 over 6 times 2 over 5 times then 1 over 4, right? So then nextly you have to open the 3 carat out of 3, right? And if you simplify this one, 3 get cancel out, 4 cancel out, this 3 times 2 is 6 cancel out, and you're left with 1 over 35. Getting it? So this is how means you have to prepare the distribution table. Now I will write all the tins that you opened here. So x in the probability of x is equal to small x, and that's a probability distribution table. So here you open the first one, so you got the probability is 3 over 7. Then nextly you open the 2 tins, so you got the probability 2 over 7, right? And then you open the 3 tins, so you got the probability of 6 over 35. Then nextly you open the 4 tins, so you got the probability 3 over 35, and you opened 5 tins, so you got the probability of 1 over 35. So this is the probability distribution table you got. Then nextly you have to calculate. So this is B part. B part is for 4 mark, and the weightage is for the probability distribution table. Why you think so they have given the 4 marks? Because this is little bit of lengthy one, so you have to prepare this whole table, write down all the probabilities correct, then and then you will get the 4 marks. Nextly you have to calculate var of x. You need to calculate even e of x. So we will firstly calculate the e of x, then we will calculate the var of x. So e of x is summation of x times p, right? Summation of x times p means you have to calculate, multiply x times this p of x, right? And then you have to write down the probability, right? So it's a 1 times 3 over 7 plus 2 times 2 over 7 plus 3 over 3 times 6 over 35 plus 4 times 3 over 35 plus 5 times 1 over 35. Here if you look at this one, you have to multiply here 5 by 5, so that all the denominator will be 35, isn't it? So you just have to add the numerator. 3 times 5 is 15, then 2 times 4 is 20, then 18, then 12, then 5, right? So it's basically around 70 over 35, means e of x you will get is equal to 2. That's it. So v of x is summation of x square times p minus e of x bracket square, e of x bracket square. So you have to write all this x square times p. X square is 1 square first of all, times p is 3 by 7 plus here 2 square times 2 by 7 plus here 3 square times 6 by 35 plus 4 square times 3 by 35 plus 5 square times 1 by 35 minus, now minus is e square, so e of x bracket square is just a 2 square. Done, that's it. And if you solve here, if you look at this one, you have a 35 35 35 everywhere. Make it here 5 by 5 as well, 5 by 5 as well here as well. So the 35 as the denominator, and add the numerator straight away. So I will make it like this here. 1 times 3 times 5 is 15 plus 2 square is 4, 4 times 2 is 8, 8 times 5 is 40 plus 3 square is 9, 9 times 6 is 54 plus 4 square is 16, 16 times 3 is 48 plus 5 square is 25 over 35 minus 2 square is 4. And if you simplify this one, 182 over 35 minus 4 is basically, if you put in the calci, you will get straight away 6 over 5 will be the answer. This is v of x. So I hope you understood this whole question. So this kind of question you will get, and there are 3-4 types of different types of probability distribution question comes each year. Okay, so you must have to practice this kind of question. And one more thing, suppose if you want to connect with us for the notes and the classes, regular revision batches, then I have left the contact in the description box. You can connect us straight away. Then nextly, we'll move on to next one, October November 2021 question. It's a paper number 51. Again, you have to make the probability distribution table first of all, and then you have to calculate the var of x. So if you look at the nature of the question, for each and every probability distribution question, it's a more or less same. You have to calculate the firstly probability distribution table, then you have to calculate the var of x, right? And then in some cases some unknown questions are then given, and then those things you have to calculate. Okay, so here probability distribution table we have to make. So to make this, here we have to read firstly question. So fair spinner has edge numbered as 0 1 2 3 1 2 sorry 2 2, and then another fair spinner has the edge numbered -1 0 1. Each spinner is spun. The number on the edge on which spinner comes to the rest is noted. The random variable is sum of, okay, so this part is very important here. This is sum of number of two spinner, means it's a just not a number, it's a basically sum that you have to put forward here. So we will firstly prepare the table. You have to write down here, you have to make the probability distribution table like this. So these are the different combination you can take, right? So here sum means 0 and -1 is -1, then 0 and 0 1, 0 plus 1 is 1, 1 -1 0, 1 and 0 1, 1 and 1 2, then here 2 and -1 is just a 1, 2 and 0 will be 2, 2 and 1 is 3, 2 and -1 is 1, right? And then 2 and 0 will be 2, 2 and 1 will be 3. So you have to make the probability distribution x is equal to sum, right? And sum, what are the different sum you got here? Firstly -1, then you got 0, then you got 1, right? Then you got 2, and then you have a 3 as well, right? So what are the probability for x is equal to small x you got? So for -1 you got just a ones, isn't it? So it's a 1 over 12. Then 0 how many times you got? 2 over 12. 1 how many times? It's a 4 over 12, right? And then 3 over 12, right? And then you got 2 over 12, isn't it? So even you can cross verify your answer here. How? basically you can check the probability. Sum of probability is 1. Sum of probability is always 1. So here 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 3 is 10, 10 plus 2 is 12. So that is nothing but 12 upon 12 means it's a 1. So our probability distribution is absolutely right. So you should be confident about this 3 marks. So this is how you can cross verify your answers, right? So then nextly you have to calculate the v of x second part. So it's also 3 marks. So firstly, before to calculate v of x, you have to calculate e of x. So to calculate e of x, we have a formula, summation of x times p, summation of x times p. What you can do? Negative 1 times 1 over 12 plus 0 times 2 over 12 plus 1 times 4 over 12 plus 2 times 3 over 12 plus 3 times 2 over 12, right? Isn't it? And the e of x, if you calculate here, negative 1, then 4, then 6, then 6. 6 times 2 is 12, 12 times 4, 12 plus 4 is 16, 16 minus 1 is 15, right? So e of x, straight away you will get 15 over 12, isn't it? Then you have to calculate the v of x. So v of x, we have a formula, is equal to summation of x square times p minus e of x, just a bracket square. Okay, so e of x bracket square. So you have to calculate it, negative 1 square times 1 over 12 plus 0 times 0 square times 2 over 12 plus 1 square times 4 over 12 plus 2 square times 3 over 12, right? Then 3 square times 2 over 12 minus 15 over 12 square. Nextly, if you simplify whole thing, you will get straight away 65 over 48. You can check it, try to solve by yourself, and then come back to this question answers, right? So that is how you can go ahead. I want to update you. Last 5-6 years, I have been delivering A star grade to all my students. Suppose if you want to connect with us for classes, notes, and understanding about the maths and physics in a better way, in a funny way, then you can contact us straight away. We have a faculty for biology, maths, chemistry. Okay, so that's it. Then nextly, we have to go through one more last question. So here is the question. It's a May-June 2022 paper number 53 and this year paper, right? So here the question says that random variable x values are there, negative 2, 1, 2 and 3. It given that p of x is equal to x kx square, where k is constant. Find the probability distribution table giving the probabilities here in terms of numerical fraction. We have to calculate the p of x quickly. So p of x is equal to small x, and small x values are given here, is equal to kx square. So if you put here x square value negative 2, you will get straight away first part, it's a negative 2 square means it's a 4, right? And then if you put out 1, it will be 1 square is 1, right? 2 square is again 4, 3 square is 9. So 4 plus 1 is 5, 5 plus 4 is 9, 9 plus 9 is total, you will get 18. So we have to put this in terms of probability distribution. So x and the numerical fraction means probability of x is equal to x. So this is numerical fraction. Numerical fraction means basically x over total, this probability summation of just a kx square we got here 18, right? So this is the numerical fraction. So we have a x values negative 2, 1, 2, then 3, isn't it? Here 4 over x square over kx square, summation of kx square is 18. Then nextly 1 upon 18, then nextly 4 upon 18, and then 9 upon 18, right? And here you can check the probability distribution table is correct or not by just observing the summation of all the probabilities is equal to 1 or not. You can check here 4 plus 1 is 5, 5 plus 4 is 9, 9 plus 9 is 18. So 18 upon 18 is basically just you will get 1, right? This is how you can cross verify your answer. right? Make sure that you will get the 3 out of 3 marks. Then next B part is you have to find out the E of x and V of x. So E of x and V of x we've already calculated in first two examples as well. So E of x is equal to, basically you have to calculate firstly E of x is equal to summation of x times p. Summation of x is negative 2 times 4 over 18 plus 1 times 1 over 18 plus 2 times 4 over 18 plus 3 times 9 over 18, right? And if you do all this calculation, you will get straight away answer 28 over 18. You can simplify this one. You will get 14 over 9 will be the, then you have to calculate V of x. So V of x will be formula summation of x square p minus E of x bracket square. So summation of x square times p is negative 2 times here 2 square, okay, negative 2 square times 4 over 18 plus 1 square times 1 over 18 plus 2 square times 4 over 18, right, plus 3 square times 9 over 18 and minus here 14 over 9 bracket square. And if you simplify this one completely, you will get straight away var of x will be 317 over 81. Okay, here you will get in the calci basically. Okay, that's it. So I hope you understood whole this concept of probability distribution first part of this video. And if you like this video, share and subscribe to our channel, share to your even friends. And if you want to connect with us, I have left the contact in the description box. That's it. Thank you. Bye bye. Take care.